Means are nothing but averages, yes or no? Now, in some method, let's say in arithmetic mean, we have some advantages. Like by the calculation method is very, very easy, yes or no? Finding arithmetic mean, it is very, very easy. Calculation part is very, very easy. That is one of the biggest advantages, yes or no? That's why arithmetic mean used to be used so many times, frequently everywhere. But it has many, many disadvantages also. If you take arithmetic mean of, let's say 2 and 4, what is the value? It's okay. The point is, how much it is deviating from the mean value. Let's say arithmetic mean of some number is coming out to be 10, let's say. Then all the other numbers, all the numbers of that arithmetic progression, how much they are deviating from 10, it doesn't matter in this case. Their average must lie at 10. Do you understand what I'm trying to say? Yes or no? Their average must lie at 10. Let's say if I give you example of, let's say, what is the arithmetic mean of 10 and 20? 15. So right now the numbers are how much? 5 unit distance from 15? Yes or no? Their arithmetic mean. Now, if I tell you to find arithmetic mean of 0 and 30, again 15. Arithmetic mean of, let's say, minus 10 and 40, 15. So it doesn't tell you how far it is from the mean value. Yes or no? You understand? Okay. In geometric mean, again, we have some advantages, disadvantages. Okay. Similarly, harmonic mean also, it has some advantages and some disadvantages. Yes or no? Now, if I say we have a well uniform, okay, uniformly placed arithmetic progression. What do I mean by uniformly placed? That the numbers are very close to that arithmetic mean. Then obviously find using the arithmetic mean concept is useful. Yes or no? See, what is the idea of a mean? Can you tell me? Let's say how many students are there? 5. Yes or no? Now, if I want to know what is the age of this group, what is the age of this class, then I will take average. Yes or no? Let's say that comes out to be 15, 16, 17, 18, whatever it is. Okay. Let's say it comes out to be 18. Now, 18, if I am taking 18 as the arithmetic mean of all of your age, then you are not far from 18. Yes or no? Very, very close. Yes or no? So 18 is taken, the arithmetic mean, the mean is taken as the representative of that sequence. You understand this? You will not be looking at each and individual value. You will be looking at only that mean value and you will assume, okay, the other numbers are somewhere near only. We are taking a representative value. Now, in arithmetic mean, we have a problem. 0 and 30, mean is 15. Yes or no? 14 and 16, mean is still 15. So representation of 14 and 16 can be taken as 15. Yes or no? But a representation of 0 and 30 can be taken as 15. Now, you understand what I'm trying to say? So there are some advantages and some disadvantages also. So in the case where all the numbers are very well distributed near the arithmetic mean, the concept of arithmetic means can be used. You understand? If all the numbers are distributed very near to arithmetic mean itself, then you can use arithmetic mean as its representation. Yes or no? Similarly, in geometric mean, this representation problem is resolved to a large extent. Even the number are very, very large. Okay. Then even then this geometric mean can be used. It represent number distribution. Yes, please quickly. In geometric mean, this representation, this dispersion from the mean value issue is resolved. Similarly, in harmonic mean also, we have some advantages, some disadvantages. Okay. So all the means that we are studying now, you must be questioning why we are studying arithmetic mean, why geometric mean, why harmonic mean. They are basically different methods to calculate the same thing. Representation of a particular sequence. Okay. Representation of particular sequence. Now, in which case, which mean you will use? It will depend upon the real life problem. What exactly you want. You understand that? You understand this? HDI, I think I have taken the example. It is the biggest example. Yes or no? They shifted from arithmetic mean to geometric mean. Anyway, so let's come to harmonic mean. What's your name? What? Vaishnavi. Vaishnavi? Okay, okay. Did you attend the Monday class also? I think I did not have the Monday class, no? Okay, okay. Please. Harmonic mean. So just like arithmetic mean and geometric mean, we will define harmonic mean also. Okay. For geometric mean, did we say that the means are always defined for positive numbers only? For geometric mean, the geometric mean is defined only for positive numbers, yes or no? But did I say anything about arithmetic mean? In arithmetic mean, did I say it is defined only for positive numbers? Now, the harmonic progression, it is nothing but reciprocal of arithmetic progression. So in arithmetic mean, we did not put a condition of positive numbers. Here also we will not put condition of positive numbers. You understand this? So let A comma B comma C be in HP. Then B is called the harmonic mean of A and C. B is called the harmonic mean of A and C. Okay. If A, B, C are in HP, then 1 by A, comma 1 by B, comma 1 by C must be in AP. 1 by A, comma 1 by B, comma 1 by C must be in AP. Yes or no? So I can apply my AP formula. I can say 2 by B equals to 1 by A plus 1 by C. Yes or no? Yes or no? 2B is equals to A plus C. Same thing here. So I can say it is nothing but B equals to 2 over 1 by A plus 1 by C. Yes or no? Can I do that? Or I can also say that 2AC over A plus C. Yes or no? So the harmonic mean of A and C is nothing but 2AC divided by A plus C. Yes or no? You understand this? Now understand this is a single value. You will get it? I can generalize this same formula of harmonic mean for any number of elements. Let's say harmonic mean of x1 and x2. It is nothing but 2 over 1 over x1 plus 1 over x2. 2 over 1 over x1 plus 1 over x2. Yes or no? If I use this formula, 2 over 1 over a plus 1 over c. Yes or no? So 2 over 1 over x1 plus 1 over x2. Yes or no? Similarly, if I expand the same concept for other numbers, more numbers, let's say harmonic mean of x1, x2, x3. So we have three numbers. So 3 divided by 1 over x1 plus 1 over x2 plus 1 over x3. Yes or no? I can generalize it for n numbers also. Harmonic mean of, let's say, n numbers, x1, x2, xn. So total number we have n. So n divided by 1 by x1 plus 1 by x2, 1 by xn. Yes or no? Quickly copy. Did you get any other material? Did you get any other material other than progression? No? Function, after that, did you get anything? For the equation, that DPP or the exercises? Exercises, no? I think theory part you already got, no? Especially that quadratic equation theory part. Okay, go through it. Those study material, it is I compiled that news those notes. Go through it. It is very conceptually prepared. How to draw the graph, everything it is there. If you don't understand anything, then you can come and ask me also. Later on, we will cover in our class also. But you have time, you are long-term students, so start going through it. Done copying? Now tell me whether it is harmonic mean of x1 and x2 or harmonic mean of x1, x2, x3 or till n number or harmonic mean of n numbers. It is a singular value or not? It is a singular, yes or no? It is single value. 2 over 1 over x1 plus 1 over x2. You will get one single value only. Similarly, second case, third case also. Okay. So we are talking about singular harmonic mean right now. So just like in arithmetic progression, we covered a topic inserting n arithmetic means between two numbers. In geometric progression also, we did cover inserting n geometric means between two numbers. Similarly, here also we'll cover that part also. Should I rub this off? Inserting n harmonic means between two given numbers. Rajni sir is covering which topic right now? Quadratic, no? Okay. Inserting n harmonic means between two given numbers. Okay. Now focus here. I am writing harmonic means. We are talking about plural numbers. Yes or no? So let's say first of all two given numbers. Let A and B be given numbers? Yes or no? Let's say we assume the given numbers are A and B. Okay. Now we need to insert an harmonic means between A and B. So let me assume, let H1, H2, H3 and Hn be the harmonic means. Be the harmonic means. Yes or no? Now all we need to do is find the values of H1 to Hn. Yes or no? Now what do I understand by inserting an harmonic means between two given numbers? That means A and B, and I am inserting an harmonic means between these two. That means A comma H1, H2, Hn comma B. Yes or no? Yes or no? You understand this? Now, just now, when ABC, when ABC, when B is the harmonic mean of A and C, then ABC were in HP. Yes or no? When B is the harmonic mean between A and C, then A, B, C are in HP. Similarly, when H1, H2, H3 till Hn are an harmonic means between A and B, then A, H1, H2, H3, Hn, B will also be in HP. The same concept we have applied to n harmonic means. Yes or no? You understand this? So if they are in HP, that means all the questions of the HP are solved first by converting them into corresponding AP. So if they are in HP, then 1 by A, 1 by H1, 1 by H2, 1 by Hn, 1 by B must be in AP. Yes or no? Clear? Now the question has converted into finding the terms of this AP. Yes or no? Finding the terms of this AP. We'll have to find H1, H2, H3. Yes or no? Till Hn. The only known things are A and B. That means 1 by A, 1 by B we know. Yes or no? Now based on these two values, we'll have to find the values of H1, H2, H3 till Hn. Now, these are n in numbers. Let's say n harmonic means. These harmonic means are total n in number. Yes or no? Now, if you include A and B also, so total n plus 2 we have. Do you agree? Same thing we have done in AP and AM and GM also. Yes or no? That means, can I say in this AP, 1 by B is n plus 2th term? Can I say? Total n plus 2 terms we have, and 1 by B is the last term. So 1 by B must be my n plus 2th term. Yes or no? So T of n plus 2. By the way, what we are doing? We know what is the first term of this AP. Yes or no? If we find somehow the common difference of this AP, then our work is done. If we have first term, if we have the common difference, then we can generate complete AP. So Tn plus 2 is nothing but 1 over B. Yes or no? Now we will apply our AP formula. A plus n minus 1 into D. In place of A, I have 1 by A. Plus n minus 1. Here in place of n, we have n plus 2. So n plus 2 minus 1. Yes or no? Into D. Now find the value of D from this equation. So if you find, what do you get? D equals to 1 by B minus 1 by A divided by n plus 1. Yes or no? Or you can write also, the right hand side also, can I rub? So if you simplify, then you will get the common difference of this corresponding AP is nothing but D equals to A minus B divided by AB into n plus 1. Yes or no? Yes or no? Now we have common difference of this corresponding AP. So we can find 1 by H1, 1 by H2, everything we can find. So 1 by H1, it is nothing but 1 by A plus D. Yes or no? 1 by A plus D. Yes or no? Or should I write 1 over A plus D? This. Yes or no? 1 by A plus D. Is it clear? Similarly, from this we can find easily H1. Yes or no? That was our aim. We needed to find n harmonic means. H1, H2, H3 till Hn can be found using this simple formulas. Similarly, H2 equals to 1 by A plus 2D. Similarly, 1 by Hn, it is nothing but 1 by A plus n into D or 1 by B minus D. Yes or no? I can write it like this also. 1 by B minus D. Yes or no? 1 by B minus D will be 1 by Hn. Yes or no? So these are the, through these values you can easily calculate what H1, H2, H1, H2, H3 till Hn. Is it clear? So our work is done here. Actually, you don't need to do this much of calculation. If you understand, if you remember our arithmetic, inserting an arithmetic mean between A and B concept, then you can directly apply that also. Yes or no? Let's say 1 by A is capital A, let's say, and 1 by B is capital B. Okay? Let's say this is capital A, this is capital B. Now 1 by H1, 1 by H2, 1 by H3 till 1 by Hn, they are an arithmetic means between capital A and capital B. Then what is the value of common difference? B minus A divided by n plus 1. Do we understand? But here capital B minus capital A, yes or no? So what do we get? 1 by B minus 1 by A divided by n plus 1. Directly we are getting this formula. Yes or no? That's all. Is it clear? But one more result we proved when we were doing HP. Sum of the n arithmetic means, do you remember? Sum of the n arithmetic means is equals to n times single arithmetic means. Do you remember that? Here also we can do that. Sum of n harmonic means between A and B. So sum of the reciprocals of n harmonic means between A and B. So I am taking reciprocal, yes or no? So 1 by H1 plus 1 by H2 till 1 by Hn. Okay? These are the reciprocal of the harmonic means between A and B. If you see it properly, then we are using again arithmetic mean properties. Yes or no? This is nothing but sum of the n arithmetic means between 1 by A and 1 by B. Yes or no? By 1 by A, it is a, let's say, capital A. 1 by B, it is, let's say, capital B. Then 1 by H1, 1 by H2 till 1 by Hn will be arithmetic means, and arithmetic mean between capital A and capital B or not? Yes or no? Now, sum of the n arithmetic means between capital A and capital B is equals to n times something, yes or no? They are single arithmetic mean. That's what we are doing. 1 by H1, 1 by H2, 1 by Hn, they all are n arithmetic means between capital A and capital B. Yes or no? The same formula we are applying here also. So it is nothing but, let me calculate, 1 by H1 to 1 by Hn, all are in AP, yes or no? If you see, if I hide 1 by A and 1 by B, still 1 by H1 to 1 by Hn, they are in AP or not? Yes, definitely they are in AP. So I can find some of the n terms of an AP. What is the formula? N by 2, A plus L, that means 1 by H1 plus 1 by Hn. What is 1 by H1? 1 by A plus D plus, this is your 1 by H1, yes or no? plus 1 by Hn. 1 by Hn is nothing but 1 by B minus D. Yes or no? This is your 1 by Hn. So D and D gets cancelled out. You will get N times 1 by A plus 1 by B divided by 2. Yes or no? Yes or no? Now look at the harmonic mean between A and B. What is the formula? 2 over 1 over A plus 1 over B? Yes or no? It is basically they are reciprocal or not? So I can say sum of n harmonic means sum of reciprocals of n harmonic means between A and B is equal to n times their reciprocal of n times reciprocal of their single harmonic mean. Yes or no? Single harmonic mean. Is it clear? Yeah, quickly copy. So in the question, if they ask, find the sum of the reciprocal of n harmonic means, or let's say sum of the reciprocal of 100 harmonic means between 5 and 20, then you don't need to calculate H1, H2, H3. What do you need to do? Directly 100 times their single harmonic means will be the sum. Okay. Wake up. You need water? You need water? Now, the questions on harmonic mean. Again, what will they ask? Insert, let's say, 20 harmonic means between 1 and 5. Should I give you those kind of questions? No. Obviously not. It is not required. You guys can do that. I can give you those questions for homework, for practice. Okay? Otherwise, that progression booklet you have got, exercise booklet, start doing it. Okay? So I'm going to start the next progression. Okay? What is our next target? AGP. What do you understand by AGP? Should I rub this off the left hand side? What do you understand by AGP? What is the full form of AGP? Arithmetic geometric progression. That means this AGP has to do something with AP and both GP. Yes or no? Both AP and GP. So when I was introducing all these progression, that time I told you only AP and GP, they are the new ones. Yes or no? All the others based on these two only. Yes or no? So let's come to arithmetic geometric progression. Arithmetic, arithmetic, geometric progressions. In short, we call AGP. Yes or no? In short, we call it AGP. Now, arithmetic geometric progression, it is nothing but combination of arithmetic progression as well as geometric progression. Yes or no? So, first of all, we will define that AP and that GP because their combination is basically AGP. Let A plus D, A plus 2D similarly is an AP. Okay. Let's say, should I say A1, 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 and let's say this. And A2, A2 into R, A2 into R square, and so B, GP. No problem. What we have done, we have assumed one AP and one GP. Now the AGP, it is basically a combination of AP and GP, but which kind of combination? It is basically term by term multiplication of the AP and GP. Okay? It is basically term by term multiplication. If you multiply term by term of a given AP and GP, then you will get AGP. That's how your AGP is defined. Understand what we are doing here? In the beginning, I differentiated between what? Your sequence and progression? Yes or no? Your progression is nothing but a sequence in which a certain pattern is followed. Yes or no? Now, based on that pattern, we divided progression in different parts. AP, it is summation. Or can I say difference between two consecutive terms? Yes or no? In GP, it is multiplication, that is R. Or can I say consecutive terms ratio? In HP, it is basically based on AP. Yes or no? Similarly, if I talk about AGP, it is the pattern followed is it is basically combination of AP and GP. Okay. So if I multiply term by term of the given AP and given GP, then the sequence that I get is basically AGP. Yes or no? What do I mean by term? If I am taking first term of the AP, the first term of GP I will take and then multiply. Similarly, second term, third term. This is what we mean by term. Or the same thing can be said, if we multiply corresponding terms of a AP and GP, then the sequence that we get will be AGP. Corresponding term or term by term, same thing. Okay. So A1 into A2. Here you will get A1 plus D into A2R. Yes or no? Here you will get A1 plus 2D into A2 R square. Yes or no? And so. If I simplify this, then what do I get? A1 into A2. Now, I will take this A2 inside and keep this common ratio R outside. Then I will get A1 into A2 plus A2 into D. Yes or no? Times R. Here also I will get A1 into A2 plus 2 times A2 into D times R square. Yes or no? So if you see this A1, A2, it is constant. So bracket part is basically AP, yes or no? 0 into A to D, 1 into A to D, 2 into A to D, yes or no? And outside we have R to the power 0, R to the power 1, R to the power 2. So we have a certain pattern again, yes or no? So this kind of pattern, it is basically known as AGP. Okay? It is basically known as AGP. Now, to simplify it, let me assume this whole value as capital A and this whole value as capital D. Okay? A1 into A2, I am assuming capital A, and A2 into D, I am assuming as capital D. So, the general or the standard form of AGP comes out A comma A plus D into R, A plus 2D into R square, and so and so. Yes or no? Is it clear? So, common ratio, it is clearly visible. Yes or no? The other term, the multiplication term with this R, we have A plus D. This R square, we have A plus 2D. Yes or no? The multiplication term with this common ratio is basically in AP. Yes or no? Is it clear? If you see, this is your A into R to the power 0, A plus D into R to the power 1, A plus 2D into R to the power 2. Yes or no? What I'm telling you is, if it is given you, this AGP is given to you in number form, then how do you recognize it? Okay? How do you recognize it? Common ratio will always be there. R to the power 0, R to the power 1, R to the power 2, and so and so. The multiplication term with the common ratio will be in AP. Yes or no? A into R to the power 0, A plus D into R to the power 1, A plus 2D into R to the power 2. That means A plus D, A plus 2D, A plus 3D, something like this. So it will be in AP. Yes or no? Is it clear? Now all the progression we have found some of their n terms except HP. Yes or no? For every progression except HP, we have found their sum of n terms. Yes or no? And AP, do you remember what kind of tricks that we used in AP? In finding the n terms, some of the n terms of an AP, which trick did we use? You are telling me the formula. I am asking about the trick. I can directly also give you the final formula. Yes or no? What I'm asking is, how did we find some of the n terms of the given AP? Reversing the order, the trick I am talking about. Yes or no? I can directly give you the final formula also. But why I'm giving you trick also? Because it can be used in solving the other questions. Maybe in trigonometry, maybe in inverse trigonometric functions. Yes or no? So remember these tricks. In GP also, some of the n terms of GP, what did we do? Multiplied with the common ratio and we moved each term one step ahead, then subtracted. Yes or no? That's how we found. Similarly, here also we have a trick. Sum of, first of all, can you find, let's say, if I write Tn, nth term of this AGP, it is nothing but, tell me, yes or no? Am I right? A plus n minus 1 into D into R to the power n minus 1. This is the nth term of your AGP. Yes or no? Which involves nth term of the AP multiplied with the common ratio power n minus 1. Yes or no? You understand this? Now, sum of n terms of AGP. Now, here also we will get a formula, but don't remember the formula. Okay? Focus on the process that we are doing. Whenever you are solving the question, you will always go through the process. Okay? You will not go through, you will not remember the formula. If you apply the formula, you will get the wrong answer because there are so many other conditions also. You will understand this. Let's say Sn, if I am talking about, then it is nothing but a plus a plus d into r. Similarly, a plus 2d into r square. Similarly, a plus n minus 1 into d r to the power n minus 1. Yes or no? Now again, what I will do? Multiply with common ratio. Okay? This whole sequence I will multiply with common ratio. So r into s to the power r into Sn. Yes or no? So what do I get? A into r, a plus d into r square, a plus 2d into r cube. So I will again shift each term one step ahead. Okay? I am getting a into r. I will write it here, a into r. I am getting a plus d into r square. So I will write it here, a plus d r square. In the end, the n minus 1 term, yes or no, will come here, a plus n minus 2 into d r to the power n minus 1. And if I multiply this, then I will get a plus n minus 1 into d r to the power n. Yes or no? All of you understand? Now, what do you need to do? Subtract. If you subtract, then Sn times 1 minus r on the left hand side. Yes or no? Now understand, this a is alone. This last term is also alone. Yes or no? So they will come as it is. Yes or no? So a plus r common. If you subtract, then what do you get? You will get only d. Yes or no? So you will get d into r. Here a common cancelled out. 2d minus d is d into r square. Yes or no? Are you able to understand? Similarly, d into r cube. Similarly, at the end of this, you are subtracting these two. So n minus 1 minus n minus 2 is d into r to the power n minus 1. Yes or no? With negative sign, minus a plus n minus 1 into d r to the power n. Yes or no? Yes or no? Now, these in between this term, this sequence, it is in GP. Yes or no? And how many terms are there? R to the power 1 to R to the power n minus 1. Total n minus 1 terms are there. Yes or no? You are following? From R to the power 1 to R to the power n minus 1. So total n minus 1 terms are there. Yes or no? So that means I need to find some of the n minus 1 terms of a GP. Do we have the formula? Yes. So a plus, what is the formula? Somebody tell me. R 1 minus r to the power n divided by 1 minus r. Yes or no? So first term, that is d into r, 1 minus r to the power n minus 2. Yes or no? Yes or no? Divided by 1 minus r minus a times a plus n minus 1 d r to the power n. Yes or no? So Sn, I can easily find a over 1 minus r plus d into r 1 minus r to the power n minus 2 divided by 1 minus r whole square minus a plus n minus 1 into d r to the power n divided by 1 minus r. Yes or no? Now it is a strange formula. Yes or no? It is a little bit complicated formula, but I cannot doubt the capacity of the student. They will, if they want, they can remember each and everything. I have seen that. Yes or no? So please don't remember this formula. I'm specifically asking. In every class I ask, please remember. But this, I am asking, please forget. Okay? Because there are so many conditions. When I give you question, you will understand why I'm saying this. You cannot apply this formula directly. This is a waste of time. Yes or no? So please don't remember this formula. Remember the process. What process? Always multiply. First step, always multiply with the common ratio. Yes or no? Then move each term ahead by one step. Yes or no? If I multiply this total sum with the common ratio r, then what do I get? A into r. I'm not writing a into r here. I'm writing with this part because if I subtract, then I must be able to take this r common. Yes or no? That's why I'm writing below this term, second term. Okay. So if I subtract, then I will get automatically GP. And some of the n terms of GP we already know. It will not take you more than 10-20 seconds and you will be able to get final answer. Okay. So what do you need to do? First, identify whether it is your AGP or not. If it is AGP, multiply with a common ratio, move it one step ahead, then subtract, then automatically what you will get, you will be able to recognize what to do. Is it clear? Quickly, copy. The next class starts at what? 10:20. So are you sure? Because last time I took the class till 10:15, I think as RK sir started telling me you are taking my time. Let me check if I can take 10-15 minutes more or not. Today is Thursday. Uh, your class starts at 10:10, not 10:20. It's okay. 5 minutes I can take. MWF 10:20. Okay. TTS Tuesday, Thursday, Saturday 10:10. Did you understand the concept? First of all, understand if your theory part is strong, so many people, so many teachers say that, focus on only solving the question. Now, first, make your theory part strong. If the base is strong, then the variety of the question asked on that concept can be easily solved. Yes or no? If you don't read the theory properly and start solving the question directly, then you will always be in confusion. Yes or no? You will always be looking at, okay, what to do in this case, what to do in this case. But if you have a strong concept, then as soon as you see the question, you will realize this formula will be used, or this concept will be used, or this process will be used. Yes or no? So always make your concept strong. Revise again and again and again. Whether physics, chemistry, or mathematics, same thing everywhere. Can I rub this off? I'll give you some questions. Okay, quickly solve this question. Quickly. Oh, we did not cover one part, that is relation between EM, GM, HM. Next time I'll cover. Okay. First, try to recognize what sequence or progression is given to you and what do you need to solve that question. Infinite terms. Can you find some of the infinite terms also? Yes or no? Find some of the infinite terms also. What will you do? First of all, this is your an, yes or no? If you want to find sum of infinite terms, that means n tends to infinity. That means you will take limit n tends to infinity, yes or no? That is one way. What is the one way? First, you will calculate sum of the n terms, then apply. Then apply what? Limit, yes or no? You will try to do that. Other thing is, what you will do? Directly consider here itself. Let's say, if it is infinite terms, then this term will not come. Yes or no? Here also, this term will not come, this term will not come. If you subtract, then what do you get? A plus this infinite series, infinite GP, yes or no?